Hi and Assalamualaikum warahmatullahi wabarakatuh. So today our group will be presenting about rules of inference for coarse discrete structure.
Hi and Assalamualaikum warahmatullahi wabarakatuh. Today I'll be presenting and covering the group member section, chosen project and the content slide. First of all, our group has 5 members. First one is Muhammad Ashraf Daniel bin Abdul Wahab. Second one is Ahmad Naufal bin Abdullah Bakri. The third one is Muhammad Amar bin Mat Nasli. The fourth one is myself, which is Ahmad Adam Zahri bin Zamri. And the last one is Muhammad Anash Imran bin Nasruddin. Moving on to the chosen project, our group chose to develop a rules of inference engine for propositional logic because propositional logic is one of the core topics in CSC510 discrete structures course. But many students find it difficult to understand and apply the rules of inference correctly. We wanted to we wanted to create a system that not only verifies whether a conclusion is valid but also automatically converts English statements into propositional logic and displays the proof step by step. This project allowed us to apply the theoretical concepts we learned in class while developing a practical C++ application. It also demonstrates how logical reasoning is used in real-world fields such as artificial intelligence, expert systems, and automated decision-making. For context, there are problem statement, project limitation, solution demonstration, and conclusion. That is all from me.
Assalamualaikum and hi. My name is Muhammad Amar. So let's have a look at problem statement. So many students find it hard to build logical proof using the rules of inference. So why it hard? Because manually proving the validity of an argument can be time consuming and prone to error, especially when dealing with multiple premises. So we create the program that can show the step-by-step reasoning and the specific rules used to reach the conclusion. Accept hypothesis and a conclusion in English represent these statements using propositional variables, which is, for example, P, Q, R, S, and so on, and then systematically apply the 8 rules of inference. And last but not least, determine and display whether the conclusion is logically valid or not.
Next is solution demonstration. I will demonstrate the inference engine system we have developed for CSC510 discrete structure. This is the main menu of our system. It offers 3 options. We will select option 1 to start the full inference process. First, we enter our hypothesis. For this demonstration, we will use example for our assignment. The system accept both English statement and logic formula. We will type each hypothesis and type done when we finish. Next, the system asks for the conclusion we want to provide. We want to prove the isodine will graduate. The system automatically converts the English statement to propositional logic. Notice how it maps each statement to a variable. This is the variable mapping table. Next, the system has determined the argument is valid. This means the conclusion student will graduate logically follow the given premise. Finally, the system displays the complete proof. It shows each step and which rule was applied. We can see that modus ponens was applied twice to reach the conclusion. Now, for option 2 is to clear all the premise and conclusion. And lastly, option 3 is to exit the system. That's all for me. Thank you.
Alright, now let me talk about the limitation of our project. While our inference engine works well for basic logic proof, there are several areas where it has room for improvement. The first one, English conversion. First, our English conversion to logic is quite limited. The system only recognizes basic pattern like if then and or. It cannot understand complex sentences, synonyms, or different tenses. For example, it will understand it is raining, but might not understand it's raining outside, or it rained yesterday. This is because we didn't implement natural language processing, or NLP. The next one, we have logic capabilities. The system cannot handle quantifiers like all or exist, which are used in predicate logic. It also doesn't include equivalence rule like De Morgan laws or double negation. So if you try to prove something like all humans are mortal, the system won't be able to process it. And the third one, we have user interface. There are no syntax highlighting to make sure formulas easier to read, and user cannot save or load their work between sessions. Everything is done through the text input. Before we have prof search. This means it may add unnecessary intermediate step to proof, and it cannot find the shortest or most elegant proof. We also limited it to 100 iteration to prevent infinite loop, which means very complex proof might be not found. Number 5, we have additional constraint. The system is designed for small-scale proof only. It cannot detect contradiction in premises, like having both P and not P at the same time. Also, because we use system-specified function like CLS for clearing the screen, the program is platform-dependent and work best on Windows. So this limitation provides good opportunities for future improvements such as adding NLP, supporting predicate logic, creating a GUI, and optimizing the search algorithm.
Next is conclusion. Okay, so for the conclusion, our work on inference engine for propositional logic has been a great learning experience for us. This project was a great way to put the concepts of discrete mathematics into practice, adding to our understanding of propositional logic and inference rules and enhancing our abilities in C++. We were able to implement all 8 rules of inference in our C++ project, such as modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism, addition, simplification, conjunction, and resolution. In doing so, we were able to construct a working inference engine that could tell whether a set of premises and conclusion was valid or not for any argument. We can also translate English statement to propositional logic and generate the proof step in our program. This would not only make our program more user-friendly, but also make it easy for those who are not familiar with the formal logic notation. The process of developing this project also gave us a chance to see how inference rules can be used in real life situations like AI, expert system, and decision making in areas like law, medicine, and engineering. Also, we have developed our programming skills in C++ and were able to write efficient, well documented C++ code. Overall, this was a very important project for us as students. It gave us practical experience and understanding of the theoretical concepts. This project will help us develop our skills and knowledge, which will be useful in our future studies and careers. I think that's all from us. Thank you.